Hi everyone, and welcome to this installment of MATLAB Programming for Engineers. In this installment, we're going to take a look at inputs and variables. Turns out we've already started looking at inputs and variables in a prior video, but what we want to be able to do today is deepen our understanding of those inputs and variables, and be able to also declare new types of inputs and variables. So after this lesson, you should be able to declare and store data in scalars, vectors, and matrices. In addition to this, I'd like you to be able to access data from these variables, as well as update data inside of these variables. And then finally, I'd like to show you a couple of special versions of these variables, or special ways you can declare these variables. So with that in mind, let's get learning. All right, so what I want to do today is just start off with a scalar example. We've already seen scalars, right? So let's see if we can retrieve that idea from our mind. What did we do when we last input data into the computer using MATLAB? Well, we set up a variable called a, and we gave it the value 1. So we took a value of 1 and put it in the variable a. So what I want to do today is I want to use an example of this so that you've got a little bit of an idea of how this might work. So here's my box here of Elmer's glue. It's an Elmer's glue box. And what I might do is I might want to call this container a variable. So I'm going to creatively call it the variable b, as you can see here. So it's a nice variable b. And what I can use this variable b for is to store Elmer's glue, right? So I can take 1 glue stick, 2 glue sticks, 3 glue sticks, and 4 glue sticks. And I can close up this box B. And that box B now contains the number 4 glue sticks, right? So there's 4. That's the number inside of B. I can take this box B and I can give it to a friend, or I can store it away for a while. And I can just leave it there on the shelf. And when I come back, I might be interested in say, whoa, take a look at that. There's the box B. I wonder what's inside. And some of you might remember that it's 4, right? So if I came back a few days later, I might not remember exactly how many glue sticks I put in there. So I might open up the box and I might pull out 1, 2, 3, 4 total glue sticks from the box. So I now know by accessing the box, aka looking inside of it, that there's 4 glue sticks inside. I can just keep them handily in there and store away the box. So this is an example of a scalar. The box B here contains the number 4. All right, so let's move on. This is the pictorial version here. The box B contains the number 4, right? And this is how we assign it in MATLAB. 4 is assigned into the box. And the actual variable itself, b, is the box, right? So we can go and we can do this in MATLAB by simply typing b equals 4. So let's go give this a try. So here we are in MATLAB, and I'm going to use my script window here to type b equals 4, right? And I'm going to now hit run. It's going to ask me to save this, so I'm going to save it as my example here. And what you can see here is that when I run example 3 for video number 3, it's b equals 4. You can also see over here that I have a variable b in which the number 4 is stored, which is pretty cool. So I have input the value of 4 into the box B, or into the container B. If I want to just see what that value looks like, I can actually type in B in the command line, and I can retrieve the value 4. So if you remember from my example, I put 4 glue sticks into the box B. That's this assignment command. So I take 4 and I put it into the container B. And then if I want to see how many glue sticks are in the box B, I can type B, hit enter, and it tells me that 4 glue sticks were in B. So that's me going to the shelf, picking up the box, and going, how many glue sticks are inside of the box? Open it up, look, and there's 4. So another thing I could do is I could recognize that there are 4 glue sticks in the box, right? I can then say, what if instead of 4 glue sticks, I want to have 2 glue sticks in the box? So I just take 2 and I put them in, right? Close up the box, store the box away. What I can do now is I can say, well, let me assign the value 2 glue sticks into the box B, hit run. And now when we take a look at B, or we retrieve or access the value of B, we see that there's 2 glue sticks in there. One of the things that we can get a little ahead of ourselves with here is we can also say, what if we took B and we retrieved B, so currently B has a value of 2, we retrieve that and then we add on 4 glue sticks. So in other words, what I'm doing now is I'm saying inside the box, there's already 2 glue sticks. So let me retrieve those 2. And let me add to that another 4 glue sticks. And let me put all of that back in, which is the equal sign, into the box. Which means that inside of this box now, I have 6 glue sticks. So let's see if that actually works out. B is updated to a value of 6, which is pretty neat. So I'm able to access the value inside of the box. I'm able to update the value inside of the box. So that is essentially what scalars do. It's a single box container, B, that you can access, update, and manipulate. All right, so pretty neat stuff for scalars. So let's go back to our PowerPoint here and just take a look at what other things we can look at. So the second example we're going to look at is a vector example. So in this vector example, what we're going to look at is not just a single box, but all of a sudden now I've got a pill box here with different days of pills in it. So hopefully they open here. There we go. And you can see that my pillbox here interferes with my recording system and gradually disappears. So let me bring it in front of myself. And you can see here that this pillbox actually has 7 different containers or days within it. So what we're going to call this pillbox here is a row vector, right? So here we're going to say that there's individual components or boxes that we can store sets or numbers into, right? So here we have a Sunday box, a Monday box, a Tuesday box, a Wednesday, a Thursday, a Friday, and a Saturday. So what might be more useful or easier is to index these boxes within this vector using numbers. So the first entry in this pillbox here, this Sunday entry over here, is actually entry number 1, or element 1 of the vector. The second entry is the second entry of the vector. The third, which is Tuesday, is the third entry of the vector. And in this case, there are 7 total entries, or the vector has a length of 7. We can see that we can also reference the final entry of that box as the last one by saying end. So let's just take this one step further and let's take a look at how many pills were in each of these little boxes here. So in the first entry there was 3, second one 2, third one 2, fourth one 2, fifth one 2, sixth one 2, and then seventh one there's 3 again. So let's go take a look here. We can create a vector variable b, right? So let me just take my handy dandy b here and let me put it on top of my vector box here, my vector pill box, right? And when I take that vector b and put it on top of the pill box, this whole box is now called b. And the first entry of b over here, b1, is actually the Sunday entry. The second entry is the Monday entry. Third entry is the Tuesday entry. So I can actually take B and look at the different days or different numbers associated with the different containers of B. So let's go into MATLAB quickly and let's see if we can create this new variable B that's a vector. So here we go into MATLAB. So what I'm going to do here in MATLAB is I'm actually going to start off with a clear all so that I can get rid of the original definition of B. And I'm going to define a new new variable B, or new container B, right? This is my pillbox container right here. There's my container B, and it had 3 pills in the first one, 2 in the second one, 2 for Tuesday, 2 for Wednesday, 2 for Thursday, 2 for Friday, and 3 for Saturday, which is my 7th day of the week in this particular box. So if I hit run for this one, what I can see is that B has now been created, let's see if I can get this, as a single row vector with 7 columns or 7 entries corresponding to 3, 2, 2, 2, 2, and 3. I can also double click on this B over here, and you can see that I have a spreadsheet entry here, which is a row of the spreadsheet in 7 columns of the spreadsheet, corresponding to 3, 2, 2, 2, 2, and 3. So what's pretty cool now is I've been able to create a vector container that has 7 entries. So let's see if we can access some of these entries from B. So here we are with our vector B. Well, if we want to access our data, we're going to use B and then a parenthesis and then the entry or entries that we would like to access. So here, B parentheses 1 should access the first entry of the box, or the first container in this element B, or the Sunday container over here. Likewise, the second B of 2 will access Monday. So let's go give this a try in MATLAB. So here what I'm going to do is I'm going to simply type B1 and B2. And when I do this and I hit run, what you can see is that the vector B is declared. And then what I get is I get the answer for the first one, B1 is equal to 3, and B of 2 is equal to 2, right? So B1 is equal to 3, B2 is equal to 2. Let's actually go in here and type B3, and what you can see is B3 is equal to 2. Let's try B end, right? So remember there was an end index. The end index is this last entry here, so B end is equal to 3. So we're able to access elements of B using the parentheses after that variable name. So that's pretty cool. Let's go back and just take a quick look at what else we can do. Well, once we know how to access those entries, we can also update or enter values that way. So remember we had the ability in our MATLAB to enter values all at once as a vector. So over here, what you can see is there's my vector here. So I've got 3, 2, 2, 2, 2, 2, 3. What I would like to now try is, what if I said B of 1 equals 5 and B of 2 equals 4, right? So what I'm going to do is I'm going to update the value of B1 to a value of 5 and update the value of B2 to a value of 4. So let's just go take a quick look and see how that works. Follow along as well if you're following along on MATLAB. And hopefully you can see in this case that the first entry is updated to 5, or B1 has updated to 5, and the second entry is updated to 4 from what it was previously. So that's pretty awesome. We're able to access those values, and then we're also able to access them and change them just like we were able to do for our box example. So the box was a simple example of this vector, right? So the box, once you can access the box, you can start changing the quantities in the box. Just like once you can start accessing the elements of a vector, you can change those values in the elements of the vector. All right, so the next step that we're going to take a look at is some really cool quick access ways that we can do this. So let's just take a quick look at this. So one of the things we could have noticed is that the first and the last entries of this box, B, contained 3 of these vitamins. On this last line here, or this next line here, I recognize the second, the third, the fourth, the fifth, and the sixth entries contain 2 vitamins each. So let's see if we can take our box B and represent it in a more compact way, like this, using MATLAB. So let's go back into MATLAB and see if we can't assign the value 2 to the second, third, fourth, fifth, and sixth entry, and assign the value of 3 to the first and the seventh entries. So here we are back in MATLAB. And what I'm going to do here is I'm going to delete this top line here. And I'm going to say B1 and 7. And I'm going to put square brackets here to indicate these are vectors. So the vector entry 1 and 7 is equal to 3. And the vector entry 2, 3, 4, 5, and 6 are going to be equal to 2. Let's just take a quick look and see what happens. So we can see the final answer we get for B here is 3, 2, 2, 2, 2, 2, 3. The intermediate one, or once we did the first entry here, or this first command, what we get is 3 and then a bunch of zeros and then a 3. So what we can see is the first command basically puts 3s at the first and the last elements of B, and then the next command puts 2s in the remaining locations. So you can see whenever we add elements to a vector, if we don't give it a value in MATLAB, it's going to put zeros there. So that's a pretty cool outcome as well. So we're kind of stacking up information here, and you're going to do some retrieval practice so that you can actually build this information a little bit stronger in your mind. So I know we're throwing a lot at you at the moment. All right, so the next thing we're going to take a quick look at is one more quick shift here. So we're going to actually go for B of 1, end, or 1, 7. We can stick with that. And instead of numbering all values from 2 to 6, we're going to enter 2, 6. And you might ask, what does that do? Well, remember, running MATLAB is free. So let's go and run MATLAB and see what it actually does. So let's go in our command window here and just type 2, 6. And what you can see is when we type 2, 6, it puts all values from 2 to 6 here, incremented by 1. So what we're actually doing here is we're replacing 2, 3, 4, 5, and 6 with simply 2, 6, which indicates we're going to go from 2 to 6 incremented by 1. So we can also do it like this, which is 2 increment by 1 till you reach 6 is another way of saying that. So I'm going to write it this way. You can write it the other way with the 1. And what you can see now is we got 3 in the first and 7th position, and we got 2 in the 2 through 6th position. So hopefully this is making a little bit of sense. All we're basically doing is we're asking MATLAB to access these positions in this pillbox and put the right number in the right box. All right. So here's what we just did. The last thing that we can do is we can recognize that the first box and the last box in the pill, the first and 7th container inside of the box B, actually has 4 vitamins in it. So I tricked you. 4 in there, not 3. So what if we had to change that? How would we do that? So give that some quick thought. Pause the video for a second. See if you can determine how you will modify the code we've written in order to put the number 4 in the first and the 7th entry. All right, so hopefully you've been given a little bit of time to think. If we take a look at this, we would change the value here to 4. And in doing that, what we're going to do is put a 4 on the first and the 7th entry. So you can see here that the value of B updated. I'm just going to move my screen up here a little bit so you can hopefully see that this is B now, has 4, 2, 2, 2, 2, 2, 2, and then 4, like that. All right, so hopefully that makes some sense. So what I'm going to suggest... So let's do a little bit of retrieval time here and see if we can try some other things. So what if I wanted to place the value 3 in the first, third, 5th, and 7th entries of this pillbox? So in other words, I want to place Sunday, Tuesday, Thursday, and Saturday. I want to place 3 vitamins in each of those container positions. How would I do that? See if you can give that a try. The second thing I'd like to do is I'd like to see if I can write a single command that gets me a value of 1, 2, 3, 4, 5, 6, 7 vitamins in their respective days, right? So 1 vitamin on Sunday, 2 on Monday, 3 on Tuesday, 4 on Wednesday, 5 on Thursday, 6 on Friday, and 7 on Saturday. So can you put that command together using vectors? All right, with that done, let's just go and do one last thing, which is to take a look at some useful vector commands. So one of the commands we've already seen is this a equals 1:10. So remember the 1: something value, or the beginning : end, sets up a vector that goes from the beginning value colon to the end value, means that we're going to increment by 1. So this a 1:10 is going to give us a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That vector may have been useful in that very recent retrieval time that we did. The second useful command that we're going to look at is b equals 1:2:10. So in this particular setting, we're going to start at 1. We're going to skip a value or increment by 2. So we're going to get 1, 3, 5, 7, and 9. And we're going to end once we hit 10. So let's just take a quick look at those in MATLAB and see what happens. So we're going to say a equals 1:10. And you can see here that it creates a vector a. It's a row vector. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can also say b equals 1:2:10, which was our second command. And that's going to take a value of 1 to begin, skip 2 to get 3, then 5, then 7, then 9. Going back to our PowerPoint quickly, what we see is there's another 2 commands we're going to take a look at. So one of them is linspace. So linspace takes the beginning value, the end value, and then how many values are going to be placed between the beginning and the end. And then the final entry here, d is equal to c primed or c apostrophe. We'll take that row and turn it into a column. So we're going to take a look and see how that works, which is also pretty cool. So let's just do this, which was c equals linspace 1:10, 5. See what c becomes. So what we see is that c is now 5-element vector. So 1, 3.25, 5.5, 7.75, and 10. There are 5 entries in that. And then we could say d equals c prime or c transpose, which gives us a column vector. And so instead of a row, it creates a column. And that's actually going to be a really nice beginning thought for our next and final section of this video. So Hopefully this makes some sense, and we are going to do a little retrieval. All right, so taking a look at this, what I'd like to do for this retrieval practice is have you take a look at the following things. So in this command b equals 1 colon 2 colon 10, what does the 2 represent? Just think about it for a second. What does the 10 represent? And what does the 1 represent? In the command linspace, what does the 1 represent? What does the 10 represent? And what does the 5 represent? See if you can explain it to yourself. And then finally, the last command is that apostrophe or the prime. So what does it mean to have a vector transposed? So if you had a row vector, what does the transpose of a row vector turn into? And then the second thing I want you to think through is, if I have a column vector, and then I take the prime of that, what does the transpose of a column vector look like? So hopefully those are some things you can think of and start to build these connections. The other thing you can do is down below here, there's going to be a link for some retrieval practice down in the description of this video. So go ahead, if you're willing and interested in to do that, go ahead and go and try some retrieval practice down there for vectors before we move on to matrices. All right, so this last segment of the video is a matrix example. So we're going to take a look at a matrix, which is essentially just a 2D version of a vector. So we're going to take a vector and just make it a tiny little bit more complicated by, instead of having a set of values in a row, we're going to have a set of values in rows and columns, which is pretty neat. So for this vector example, I've got this set of hardware here, this hardware bin of mine, and it contains all different kinds of hardware in it, right? So screws, rubber bands, caps, plugs for the wall. I've got some rubber washers in here, all kinds of things in here. So in this hardware bin, what I might be interested in is how to determine how much of a certain piece of hardware I've got. So I've got a set of rows in this hardware bin, and I've also got a set of columns. And this hardware bin essentially becomes a matrix or a 2D container, right? So it's got rows and columns. It's a 2D version of my box here that contain my vitamins, which is a 1D version of this point container, the box, right? So we just are building more and more complexity into our examples here. Okay, so the matrix example here is this hardware box, and now you can see the actual hardware inside. So there's my hardware box, and the number of rows in this hardware box is 4. So the rows are the horizontal rows, just like on a spreadsheet, right? So they're the rows. There are 4 rows in this box, and there's a total of 6 columns in this box. So what we tend to say is that this matrix has 4 rows by 6 columns, or a 4 by 6 matrix. And the total number of individual containers or locations where I can store numbers is 24, or 4 times 6. So in order to assign values to these matrices, what I can do is I can write the matrix values. So here I've just put H for hardware box, right? So H is equal to 2, 3, 4, 2, 3, 1. The commas separate different columns of that matrix, right? So the columns are separated by the commas. The rows, or to start a new row, I put a semicolon, right? So I put semicolon 3, 5, 2, 7, 0, 3, semicolon, right? So I go to the next row. So you can think of the semicolon as go to the next row, like a typewriter, go to the next row, zzz, right? And the commas are separating the columns or the column entries from each other, right? So let's take a look and see if we can pull this into MATLAB. So I'm just going to bring my definition for H here into MATLAB. And I'm pretty sure I'm not going to get the same H here, but I'm going to give it a try. So here I'm going to say H equals 2, 3, 4, 2, 3, 1. Semicolon, right? Then I can do 3, 5, 2, 7, 0, 3. Semicolon. 6, 2, 2, 1, 0. You can see this takes a little bit of time to get the input in. So 7, 2, 1, 2, 4. And I hit enter. And what I can see is I now have produced a matrix version of H, right? So this is a matrix entry of H. I'm just going to copy this into my script file up here. And I'm also going to write it with each row of the matrix as a separate line like this, just so you can see how this works also. So if I hit run here, you can see that this will also work. It's a little bit more visually appealing to see it in this format in the script file. So there I've managed to put the value of H into MATLAB as a matrix or as a set of row and column values corresponding to those locations. So the next question that you might ask yourself is, how do I access these entries in MATLAB? So how do I access each of these entries? Remember, so we can store or input stuff into the box, right? So we can put stuff on the box, put it on the shelf, or we can put stuff into our hardware box now and put it on the shelf. But let's say someone wants to know how many screws there are in this box over here, right? How do they determine that? So how do they access that box and get the number of screws in that entry? So they go over to the shelf and they ask MATLAB for that value back. So let's take a quick look at how we do that. So to access the elements, what we're going to do is type H and then parentheses. Instead of a single entry like we did in vectors, we're going to do the row, comma, column index. So here, this is the first row, first column. So we're going to say H11. If we wanted the first row, third column, we would say H13. If we wanted the first row, last column entry, we would say H1, end, right? And we would go through our system that way. So let's just take a quick look in MATLAB and see how this is going to work. So let's type in here H of 1, 1, and it should produce what value? In this case, it should produce the value 2, and sure enough, it does. Let's produce the H of 1, end. So the first row, last value. So let's take a look at our first row. Last value is 1. So this should produce a value of 1, or should access this value of 1 over here. Let's try and access this value of 4 down here. So that's going to be the fourth row, sixth column. So we're going to say H of the fourth row. We could also say the last column, which is end, which is 4, right? So that's the value 4 was being stored there. We could also say H of 4, 6 is equal to 4. So we want to get this value 7. That would be the fourth row, first entry. So we could say the fourth row, first entry is 7. We could also say the last row, first column, which is also equal to 7. So you can see in MATLAB, we're able to access these values. So I can also say, I want this 2, 2 value, which is going to be on what we call the diagonal. It's going to be this 5 here, the second row, second column. We can then say third row, third column. this, and we can get this, the value of 2, and we can get the 4th row, 4th column, like this, and that should be the value 1 over here. So perfect. We're able to access entries. So how about if we wanted to change the values of those entries? Well, we're going to have to go back here, and hopefully you've got a bit of an idea on how to do this. How would we change the values? So see if you can apply what we learned in vectors to changing the 1, 1 value. So let's do some retrieval. Okay, so looking at the PowerPoint, if I wanted to access and change the h11 value, I would say h11 equals 2, which means I'm taking the value 2 and assigning it into h11. Similarly, if I wanted to change the 1,3 entry, I could assign the value of 4 into h13. So let's just take a quick look at how we can change those individual matrix entries. So here, let's take a look at h. There's my h matrix. So let's say h of 1, 1. We want to change, instead of to the value of 2, let's make it a value of 100. And what we see is that 1, 1 value changed to 100. We can similarly change the 1,3 value to 100, the 1,5 value to 100. And in order to just pull up this set of commands, I just press the up arrow just so that you know. I can also change the last row, 5th entry, to 100, the last row, 3rd entry, and the last row, 1st entry. So you can see here, I'm able to access, just like in the case of the box, I was able to pull the box off the shelf and put new values in the box and then put it back on the shelf. Similarly, I'm able to pull the hardware tray off the shelf, put new values into that location, put the hardware box back on the shelf. So hopefully that's making a little bit of sense. So one of the interesting things or useful things to do in MATLAB is to actually also access and change full rows of the matrix or full columns of the matrix. So we can access a full row of the matrix by saying h1 for the first row, 1 colon end, or just h1 comma colon to get the full first row. Similarly, we can get the 4th row by h4 of 1 to the end, or h4 of colon. So this is best done by just seeing it. So let's take a look at MATLAB again. So here I'm going to say h of 1 comma 1 colon end. So this is going to say, let's take the first row, and then let's take columns 1 through the final column. Oops. And what we can see here is that we get 1 through end. So we get the first row, all of it, right? I could similarly have just written and ignored the 1 through end and taken all of them by taking colon here, and it would still give me the first row. So just taking a look at h, it gave me that first row. If I wanted to do the last row, I could do end, the last row of that, which is 100 to 101, 104, right? So that's the last row there, which is perfect, right? So we can access a full row. Similarly, we can access a full column. We'll see that in a second here, but let's just go back and see if we wanted to assign a value to a matrix row. We could access that value or that row. So we could say, let's take the first row, let's access it, and then let's change the value to a value of 5, or let's change the value to an increasing value of 1 through 6. So let's see this in MATLAB itself. So we're going to say, let's take the first row and change it to 5. Let's take the last row and change it to an incrementing vector of 1 through 6. So let's see what happens. So let's just take a quick look at h. If I take h, the first row, all entries, and set them equal to 5, you can see that the first row, all entries are now equal to 5. Similarly, I could take h, the 4th row, 1 through 6, or I could also say all entries is equal to 1 through 6, I think is what we were trying to do. And we can see from this command that we're able to change the fourth row to a 1, 2, 3, 4, 5, 6 incrementing vector. We could also have done 1, colon 2, 12, and we would see we'd get 1, 3, 5, 7, 9, and 11. So we can really go into matrices and start manipulating, accessing rows, accessing entries. We're going to see accessing columns here in the very next example. So accessing columns, in order to access a column, what we're going to do is we're going to do this. We're going to, instead of taking a look at the 1, colon value, we're going to do colon, 1. So here we're going to take a look at all rows in the first column. So that's how this syntax works. Let's just try it in MATLAB. So H, let's look at our H matrix. Let's try and access the first column of this H matrix. So 5, 3, 6, and 1. We're going to say H of all rows, first column, right? And if we do that, we're taking this box and we're accessing all rows. So colon means all rows, or 1 through n. And we're taking the first column. So the first column entry is this column here. So let's take a look and see how that looks. There we go. It's 5, 3, 6, and 1. Let's take a look at H again. Let's take a look and see if we can't get the last column. So we can do end, and that will give us the last column. We could also do the third column. Let's just make sure that we get the third column here. So the third column is 5, 2, 2, 5. The third column is 5, 2, 2, 5. So pretty neat stuff. We're able to access whole columns of a matrix. We could also, this is kind of fancy, do 2 to 4 and 2 to 4, right? So what did that command do? If we take a look at this, it took the second through fourth entry and second through fourth column, right? So it takes second through fourth, so 5, 2, 7, 2, 2, 1, 3, 5, 7. Let's go see if it actually did that. So 5, 2, 7, 2, 2, 1, 3, 5, 7. So we're able to actually extract portions of matrices by giving a range of values in the rows and columns entries, which is also a pretty cool extension of what we've been doing. All right, so that's how we access matrix rows and matrix columns. The last thing we're going to do here is just talk quickly about a couple of useful matrix commands. So here's a couple of ways you can declare some pretty cool and quick matrices. The first ones are ones and zeros. So if I come over here, I can type in the following. So I'm just going to CLC here. I'm going to say A equals ones. And let me actually bring MATLAB here. There we go. So A equals ones of 5, 2. Let's see what happens, and I'll explain what it is. So what it does is it sets up a matrix of ones. That's what ones does. And it has 5 rows, 2 columns. So A equals ones, 5, 2. Similarly, I can do 2, 5, and instead of ones, I can ask it for zeros. And it will produce a 2 row by 5 column set of zeros. So 2 rows, 5 columns. Pretty good, right? So you can actually do some quick stuff with creating some very quick matrix container. The last two are going to be random and then transpose. So let's take a look at those. So C equals rand of 5, and then that's transpose. See what the transpose command does. So here we are. Let's CLC here quickly. Let's do C equals rand 5. And what we can see is we produce a 5 by 5 matrix C of random numbers between 0 and 1. We could also do C, instead of rand 5, let's do 2, 3. So it's going to have 2 rows and 3 columns. So it's a 2 by 3 matrix right here. It's got random numbers in it. Very, very useful for probability and statistics and other things where you need random numbers or a random number generator. So the last thing that we said we're going to do is D equals C prime or C transpose. So C currently is a 2 row by 3 column matrix. If I do the transpose, I get a 3-row by 2-column matrix. So what the transpose did was essentially took C and rotated it 90 degrees to make it a transpose of the original matrix. So those are some of the tricks. And what we're going to do is just take a quick look at some retrieval practice. So on the retrieval today, we're actually going to do the retrieval as part of our summary. So our summary here is the following. We should be able to now declare scalars, vectors, and matrices. So what I'd like you to do is take a moment and think through what were the differences between scalars, vectors, and matrices. See if you can write down 2 differences or 2 unique things about each of those. Also see if you can write down a couple of things that are different in MATLAB when you declare them. So how do you declare a scalar? How do you declare a vector? And how do you declare a matrix? What are some of the ways you can do that? The other thing I'd like you to think about is how do you access a scalar, a vector, and a matrix? So see if you can write those down right now without looking, without checking back at your notes or rewinding this video. Can you access those values? And then the last thing I'd like you to try is, can you change those values? So can you update the data in a scalar? Can you update the data in every other entry of a vector? How about, can you update a square of entries in the middle of a matrix? So can you take a 2x2 matrix within a larger matrix and update those values? See if you can think through those. Those would be really good practices. And if you want to carry on your practice and see if you can reinforce and improve your connections in your brain, go down below, take a look at the retrieval practice provided. Give it a try there if you feel comfortable doing that, and see if you can't reinforce some of the things that you've learned today. And the final thing that I want you to think about is, what were some of the special values or matrices and vectors that we looked at? So how did linspace work? How did that colon operator work? How did ones work? How did zeros work? And how did rand work? And then the final thing I'd like you to try to do is to connect the idea of matrices and vectors together. So how are matrices and vectors related? This is a really good retrieval practice to see if you can come up with a way to define how a matrix and a vector in MATLAB are actually pretty much the same thing. So think about that, and until next time, take care.